Welcome to the next episode of our series Groundwater. In this episode, we are dealing with the geological work of groundwater. So, any geological work means it includes three processes: erosion, transportation and deposition. So, here the geological work of groundwater involves mainly three processes, that is erosion, transportation and deposition. Through the rock opening, groundwater brings about weathering and erosion of the rock, transportation of the product of weathering and deposition of the transported material at suitable condition. So, groundwater brings about erosion mainly through chemical process, so that is mainly by the solution action. So, only through the solution action groundwater performs erosional work, which is particularly effective in regions of soluble rocks like limestone, dolomite, gypsum and anhydrite, rock salt, etc. Now, we will deal with the erosional features of groundwater. First erosional feature discussed here is about lapis. So, it is an erosional landform produced by the groundwater. When limestone is disintegrated by solution process, it leaves behind a clayey residual soil known as terra rossa. So, once due to the solution action, limestone rock leaves behind a clayey residual type soil. So, this type of residual soil is known as terra rossa, means in Latin word it means red earth. When erosion removed the overlying soil, the limestone bedrock can be seen. On some of these surface and elsewhere in the near surface, limestone joints are opened and widened into fissures known as creeks. The rounded upward projecting surface of the remaining limestone are known as lapis. So, when groundwater moves along the limestone region, it produces a highly undulating topography by the solution action and it enlarges the fractures or joints in limestone region to a complex pattern of cliffs and ridges. This surface is called lapis or limestone pavement. So, here because of this solution action, the limestone has removed the clayey material, the top surface is eroded and the remaining boulders, it appears like cliffs and ridges. This type of topography you can call it as lapis or limestone pavement. It looked like just pavement. In this picture you can clearly see in the lapis. So, there are so many grooves in between this rock. So, it is by the solution action groundwater has removed that finer materials, remaining bedrock looks like pavement and this type of pavement you can call it as lapis or limestone pavement. So, this is a very good erosional feature produced by groundwater. When groundwater moves along limestone region, it produces a highly undulating topography by the action of the solution action and it enlarges the fractures or joints in limestone into a complex pattern of cliffs and ridges. This type of surface is known as lapis or limestone pavement. You can see in this figure, this is the limestone bedrock. In between the bedrock, there are so many gaps seen. So, these gaps are produced by the solvent action. So, by the solvent action, the intervening beds are removed and the limestone looks like a pavement. This type of limestone pavement can be called as lapis. So, this is also the typical diagram for the lapis. So, terra rossa is that fine grained red colored soil produced by the weathering of the limestone rock. The remaining structure looks like lapis. Next feature is sinkholes. It is a large solution cavity, maybe several meters in diameter, open to the sky. These are also known as dolines, sinks, shallow holes, etc. So, these are also holes produced within the ground, mainly produced by the solvent action of groundwater. So, it is having several meters in diameter, usually opens to the sky. This type of erosional feature can be called as dolines. So, this is the mechanism in which dolines are formed. So, initially this is the terrain, once there is a small gap produced and the gaps usually enlarges and it becomes a large hole, deepened and widened. So, this resulted into the formation of solvent action. So, this is a erosional feature mainly produced by the solvent action of groundwater. So, this is another picture in the ground, it is a hole. So, this type of holes you can call as sinkholes. This is also a typical picture of the sinkhole. You can see a large depression within the ground. So, it is mainly produced by the solvent action of groundwater. Next erosional feature is caves and caverns. So, caves, as you all know, is a naturally formed subsurface opening that is generally connected to the surface. Just like a normal cave is a naturally formed subsurface opening, whereas a cavern is a very large cave or a system of interconnected caves. So, there are so many interconnected caves, it looks like a cavern. So, caves and caverns, these are all produced by the groundwater erosional action. Horizontal linking passages between the caves are known as galleries. So, the caves are interconnected or linked by horizontal passages known as galleries, and vertical linking passages are known as shafts. So, horizontal galleries and vertical linking passage is known as shaft. So, sinkhole and associated picture is the cavern. Cavern is a series of caves. This is also a picture of cave. Inside that you can see so many depositional type features. The actual thing is a cave inbuilt and there are so many features produced within the cave. So, this is a cave. So, cave is mainly produced by the solvent action of groundwater. Groundwater, when it is stored within the pore spaces by the solvent action, water also consists of so many dissolved salts. So, these salts acted with the rock surface and slowly weathering will take place and a series of structures are formed. So, cave is a hollow produced within the ground. So, these type of features are mainly produced by the solvent action. Next is karst topography. So, karst topography means it is a particular type of topography produced mainly by the solvent action. So, in an area where the main type of weathering is dissolution, the formation of caves and sinkholes and a collapse and collisions may result in a higher irregular topography known as karst topography. So, due to the continuous action of this groundwater and by the solvent action, the entire topography changes it into a particular type of topography known as karst topography. So, karst topography is a topography produced by the erosional work of groundwater. So, it consists of caves, sinkholes, then caverns and all that things, and in future what happens is there is collapse and collisions of the top of the caves and all, resulting topography you can call it as karst topography. So, it is a landscape where the surface of the bedrock, usually limestone, has been dissolved by the groundwater, forming an irregular surface and subsurface. So, actually it is a topography mainly produced by the limestone rock, mainly due to the solvent action. So, it is having sinkholes, caverns and etc. So, this is a topography, you can see that topography here, and it is a limestone area. So, this limestone is easily subjected to weathering. Limestone is nothing but calcium carbonate. So, it is easily weathered by the rock. So, rock weathered, and the limestone rock is weathered, and due to the solvent action of groundwater, this groundwater is stored within this particular rock. So, by the continuous action of groundwater along with the rock, what happens is the rock is subjected to weathering and ultimate product refers to the karst topography. You can see the sinkholes and so many other things. So, the entire thing you can call it as karst topography. This is also an aerial view of the karst topography. So, here you can see so many sinkholes, so many depressions. So, this entire area changes it into a particular topography, and that topography is referred to as karst. So, that means karst means that land, the entire area becomes a barren land. So, due to the continuous action, the rock is subjected to weathered, and due to weathering, so many holes, caves, caverns and everything is produced. The entire topography is known as karst topography. So, these are also pictures for how this happens. Slowly the rock is subjected to deterioration. So, the water is stored within the pore spaces of the limestone rock, and this is mainly seen in limestone region. Next is solution valleys. So, solution valleys are caused by the collisions of sinkholes and locally contained disappearing streams. So, valleys, as you know, valleys are caused by the collisions of sinkholes. If the sinkholes collides in the sense if it collapse, so it forms as valleys and locally contain disappearing streams. So, if it is a valley, you can see some sort of disappearing streams. In some time there is water in the stream, so it looks like a stream. Sometimes the roof of a cavern may collapse, enlarging it in an upward direction. With continuous solution action, the collapse may reach the surface and a hollow, usually elongated and narrow, and produce the solution valley. So, solution valley is also a valley produced by the solvent action of groundwater. So, groundwater is stored within the pore spaces of the rock. By the continuous action of groundwater along with the rock, it is subjected to disintegration and ultimately valleys are formed. So, this type of valleys formed by the erosional action of groundwater can be called as solution valleys. Next is natural bridge. So, bridge, you know, it is a connecting link between two points. It represents the remnant of the roof of a cavern. So, here you can see a bridge. So, it represents the remark of the roof of a cavern. A cavern roof, it is a remark of the roof of the cavern. So, here in this picture you can see a bridge connecting between two caves or two caverns. This is it looks like a real bridge. So, once the action continues, what happens? The bridge may collapse. So, in this picture you can see a fallen thing. So, that bridge just collapsed due to the continuous action of groundwater. So, the another point is in this type of bridge, the next step is the collisions of the bridge. So, the roof may collapse. So, this is also an erosional feature produced by the erosive work of groundwater, mainly seen in limestone region. Next is polch. These are large depressions occurring mainly due to the roof collapse over great karst chambers. These are also just like sinkholes, these are also large depressions occurring mainly due to the roof collapse. Once the roof of the thing is collapsed, of the roof of the cave is collapsed, what happens is it looks like a large depression. So, this type of depressions can be called as polch. So, these are also common in karst chambers. They are characterized by large size, flat bottom and shape of a closed basin with steep sides. It is having large size. Polches are mainly seen in large size depressions, flat bottom, and the shape is almost like a closed basin with steep sides. This is a typical picture of a polch. So, it is a depression, and this depression is mainly of basin shaped and large size with steep sides. So, it is having both sides are steep side, all the sides are steep. So, this is also produced by the solvent action of groundwater. This is also a polch depression. So, you can see this type of depressions. So, depressions are formed due to the solvent action. By continuous action of groundwater within the particular rock, the rocks are subjected to slowly disintegration, and so many depressed things are produced, and this is known as polch. Next erosional feature is stylolites. Stylolites are irregular surfaces occurring in certain rocks, mostly seen parallel to the bedding planes, in which small tooth-like projections on one side of the surface fit into cavities of like shape on the other side. They are most common in limestone and dolomite, but are also present in many other kinds of rock, including sandstone, gypsum and cherts. So, this is also another erosional feature. So, here you can see irregular surface mainly seen parallel to the bedding. Bedding means almost the layers are seen parallel. So, in sedimentary rocks it is a layered rock. So, this irregular surface occurring in certain rocks parallel to the bedding, in which small tooth like projection. So, one side of the tooth like projection fit into the base next side. So, it looks like tooth like projection on one side of the surface fit into the cavities of like shape on the other side. So, both sides one fit into the socket like this teeth and socket. So, these two fits like teeth and socket. So, it is a teeth like projection seen, and it is mostly seen in limestone and dolomite region. So, if the country rock is mainly of limestone or dolomite, you can see this type of erosional feature, and also consist of in sandstone region. Sandstone, you can see that sandstone is a calcium, it is also silica type rocks, sandstone, gypsum, chert, these are also commonly seen in these type of rocks. So, this is the picture for stylolites. You can see the beds. So, that layer by layer are the various types of beds. So, it is a clay, the rock type is clay, and you can see the teeth like projection. So, one projection in one thing and the corresponding projection in the next thing. So, these two it looks like teeth and socket. So, this type of irregularly shaped feature seen in limestone and dolomite area are known as stylolites. So, these are also the same picture for stylolites. You can see irregularly placed teeth like projections. So, these are formed mainly by the erosive work and mainly by the solution action. So, here that irregularly spaced structure can be clearly seen. So, that irregularly thing is formed or produced by the solvent action. So, we can go back once more to the geological work of groundwater. So, geological work, it includes mainly three processes: erosion, transportation and deposition. So, we can look into the erosional process. So, mainly groundwater performs erosion by solvent action or solution action. So, due to the continuous action, solvent action, the country rocks are subjected to disintegration or weathering, and the resulting landforms produced are the main erosional landforms produced by the groundwater. The first thing we mentioned is lapis. So, this lapis are produced by the erosive work of limestone, and it consists of irregularly shaped fractures or joints in limestone, and it looks like pavement. So, when erosion has removed the overlying fine grained soil, the remaining area looks like a fissured thing, rounded upward projecting surface. It looks like a limestone pavement or lapis. The second thing erosional feature is sinkholes. It is also a large solution cavity produced by the solvent action of groundwater. So, it is several meters in diameter and it is open to the sky, also known as dolines, shallow holes, etc. Next is caves and caverns. So, caves and caverns are usually interconnected. So, caves are naturally formed surface opening, subsurface opening, and cavern means series of large caves or a system of interconnected caves, you can call it as caverns. And the horizontal linking passages within the cave is known as galleries, and vertical linking passage you can call it as shaft. Next is karst topography. So, karst topography means it is a special topography produced by the solvent action of groundwater. So, erosive topography mainly produced by groundwater, and it comprises of this sinkholes, caves, caverns and all. So, normally by the solvent action the roof of the caves, caverns and all collapsed, and the entire topography you can call it as karst topography. So, here in this picture you can clearly see the topography here. So, there are so many depressions, all the top surface are eroded by the groundwater action, by the solvent action, the remaining things looks like a karst topography. Next is solution valleys. Solution valleys we discussed about the valleys. So, just like normal valley, it is also formed by the collisions of sinkholes, and usually by the collisions of sinkholes the normal terrain appears to be a valley. So, these type of solution valleys are formed by the solvent action of groundwater. Then another feature we discussed is about the natural bridge. So, natural bridge represent the remark of the roof of a cavern. So, the roof of a cavern looks like a remark. So, it is referred to as a natural bridge. Then polge. Polge is a large depression mainly formed by the roof collapse. So, karst chambers are there. So, once the chambers, the roof is collapsed, it looks like large depression. So, these depressions can be called as polge. And about the last point regarding the erosional feature we discussed is about the stylolites, and stylolites are irregular surface that seen parallel to the bedding planes. It just look like teeth like projection which having a teeth and socket. It fit into the two surface or which fit into the two planes, and it looks like irregular surfaces. Let me conclude this session here. I hope you understood the topics discussed in this session. The next session we will deal about transportation and deposition of groundwater. Till then, bye.